So, if we're doing angular projectiles, so yesterday, right?
30 degrees at 100.
We were shooting Ava, who's not here.
Yeah.
Is she okay?
She's in the cannon. Yeah. She's in the cannon.
She's in the
I
cannon.
think she might be going to
Okay? So we said we were going to launch her, right? And we said that the angle that she made with the ground, oh, that's good.
All your markers are live, kid.
I don't know. There you go. Was 30 degrees, right? And we said her initial velocity was 101 meters per second. So we had set up our key, okay? And inside our key, right, we had our initial velocity in the x, our final velocity in the x, our acceleration in the x, our displacement in the x. Same thing with the y. The only difference was we were talking about sy max, right? And then we said we had our independents, which were the change in time, the initial velocity, and the angle.
All in a day's work.
And the what?
I said all in a day's work.
All the day's work, yes. Okay? Yes.
Vx is the same as Vi, right?
VIX. Yeah, sorry, we're going to sorry. Okay? So we had that. And so we had said, okay, our VIX, right? If we look at the key, if we look at the picture as we're getting into it right now, what can we fill in the key?
A1?
Just based on the picture right now.
Oh, the theta.
Theta, we can say is 30 degrees. And what else?
VI is 101.
And VI is 101 meters per second. That's all we can do based on the picture, yes? Now, what we said we could do is we said we could take this velocity and we could break it up into its two components. One component being the VIY that goes up, the other component being the VIX that goes across, or vertical and horizontal, yes? Okay? And we said we did those two things using the AX and the AY formula. Yes?
Yep.
AX equals A cosine of theta. AY equals A sine of theta.
Wait, is the 101 like VIXY?
No, the 101 is VI by itself. It is the resultant velocity. It is just it is independent of the x and the y. It is the resultant. It's in between the two. Okay? That's why we kind of put it in that independent section. Okay? And so we used this formula yesterday, right? And we were able to figure out that your VIX came out to what?
15.5.
15?
Yeah.
No.
That was quick. The VIX, the cosine one, got 87.468.
This one should be 87.5 meters per second. And the VIY? 50.5. Kelly, do you understand why?
Yeah. I got it.
Okay? Does that make sense? Yes? Good? This is just what we did yesterday in class.
Well, we got up to we didn't actually solve it. You said we could come up.
We said solve it for homework, I told you to do. So you should have solved it for homework, right? So it should have been 101 times the cosine of 30, 101 times the sine of 30, ensuring that your calculator is in degree mode. If your calculator is not in degree mode, you're going to get the wrong answer. Okay? If you're in radians, you're going to get the wrong answer. So ensure that your calculator is in degrees when you do this. Okay? Cool? Yes? All right. So, when you do that, you know these two values. Now, you know other values as well, based on what we've done with free fall motion and projectiles and all those other things. What other values do you know that are in this key right now? Kelly, give me one. VFX?
Yes.
How?
Because VIX and VFX are always the same.
Why? You got to give me another value before you can say it. You're right, but you got to give me the value.
Acceleration is
The,
0.
the acceleration in the x is 0. Because we're assuming that there is no air friction, air resistance, or anything like that. That's what
AY is negative 9.81.
AY is negative 9.81 meters per second squared. Because we're assuming this is on Earth, it didn't say it was on Pluto or Krypton or something else. Okay? Now, Kelly, since you know this is 0, now you can say that this and this should be exactly the same. Does everybody understand that? If you have no acceleration, it means whatever velocity you start at is the same as the velocity that you finish at. Okay? We don't know this. We don't know this. We don't know this. And we don't know that.
Which one knows? Why are we looking for SY now?
Because one of the questions we asked was how high does she fly?
Oh, okay.
So yesterday, remember we asked those 4 questions?
Yeah.
How long is she in the air? How far does she travel? How high does she go? And how fast is she going when she gets there? Yes?
So VIX and VFX will always be the same when acceleration is 0.
Yes, ma'am. Good? Cool? Everybody understand that? Okay, so what do we need to do next?
So over time.
Time is probably the easiest one, right? Now, if we look at this trick, okay? So I'm going to erase this just so we can just draw the pattern, right? She wants to shoot off into space like this, yes? But does she? No, she doesn't. Why? Because when she comes out of the cannon, what grabs her? Gravity. And gravity starts to pull her down. And so yesterday we said that she ends up taking a path that looks like that, parabola, yes? Now, if we look here, right? When she takes off here, right? She has this velocity in the y and this velocity in the x. We just figured out 87 and 50. Yes?
Yep.
If we were to go, let's say, a second into the future, okay? So we went to here. Okay? Would her velocity in the x change at that spot? No, because her acceleration is a big fat 0. So she'd still have a nice long line. Yes? But would her velocity in the y be the same here? Why not?
Because gravity.
Gravity's trying to pull her down. So her velocity in the y would be a little bit shorter. Yes? A little bit less? What about if I went to here?
Be shorter.
Okay? The x would still stay the same. Right? But the y would be even shorter. Does that make sense?
The VIY.
Oh, it looks like a jump down. Yeah.
Right? Now, when she gets to her highest point, right there, yes? That's the apex.
Oh, there's no VIY.
Okay? What would her velocity be in the y? 0. Because at the apex, think about every question that we've done, whether we shoot her up in the air or we kick them off a cliff, right? At the highest point, your velocity in the y is always a big fat 0. So here, your velocity in the y would be a big fat 0. Now, is she not moving? She's still moving, but which way is she moving? Forward. Only in this case is she moving forward. Everywhere else, every other dot, she's moving both forward and
Down. Well, upward.
up. Which way is she moving here? Forward and
Up.
here?
Forward.
Here, she's just moving forward. Does that make sense?
So,
Down and up.
Yes.
so because it's at apex, it's just forward, but then like, let's say.
We'll get that. Don't go ahead. Don't go ahead. Give me a second. I know what you're going to say. Give me a second.
Sorry.
Okay? Now, so at the apex, we know her velocity in the y. Not her total velocity, but her velocity in the y is a big fat 0. Does everybody understand that? Now, once she goes over the top of the hill, over the apex, right? Let's say we went to this dot here. Would her x change? Her x? No, her x stays exactly the same. Her y, now which way is she going? Down, right? She'd have a y now that's going down. What about here? Okay, her x would still be the same, right? But her y would be a little bit bigger in magnitude, yes? And when she gets down here, right? Her x is still the same, right? Same length. And her y, right? Now, the magnitudes are the same for these, yes? Right? As over here. Same height, it's going to be the same velocity, yes? But what's the difference going to be between, let's say, this height and this height? This one would be negative and this one would be positive, yes? Yes? So as she goes up, vertically she slows down, goes over the mountaintop, and then vertically starts to speed up. So what's the value of this one?
Wait, are you talking about?
Right where she lands.
Velocity?
What would be the velocity of the y right as she lands? Marcus?
It would be negative 50.5.
It would be negative 50.5. Because she goes up to a certain height and then comes down that same exact height. This is just like the questions where we threw it up and then it came back down. Yes? Does that make sense? So this down here would be your VF Y. Yes? This would be your VF X. Does everybody understand that? We know our VFX is 87.5 meters per second. Yes? What would our VFY be? Negative 50.5 meters per second. It's negative because it's going down. Yes, sir.
And this is true for all questions because the x only moves in one direction and y is up and down.
Very good. Okay? Now,
Can I take a picture?
wait until I'm done. Okay? My question to you then is what's the value of my VF, my impact? How would you figure it out? Mathematically, how would you figure it out? Kelly? Pythagorean theorem. A squared plus B squared equals C squared. So let's do it. A squared plus B squared equals C squared. So VFX squared plus VFY squared equals C squared. So 87.5 meters per second, square that, plus 50, negative 50.5 meters per second, square that, equals C squared. What do you get?
Oh.
See, somebody got it. Well, let everybody do it. It should be an interesting answer that you get.
Yeah. It makes sense, you know.
Nicholas, what do you get?
It's the same as the initial velocity.
Which is?
101 meters per second.
101 meters per second. How many people got 101? Okay. Why? Why do you get that? Well, because you take off from here and go up to a certain height, yes? And then you come back down the exact same height. Gravity acts exactly the same going up as going down. So, if you're ever asked for the impact velocity of these questions, do you have to do the work? No. Your impact velocity is always the same as your initial velocity, assuming there's no what? Air resistance, which for our sake we will. Yes, sir.
I got a different answer, but
How?
No. Is 50 positive or negative?
It's negative.
Wait,
Oh,
what's
I
the
don't know
limit?
how I got it.
Doesn't matter. Negative 50.5 times negative 50.5 gives you what? Did you not use the parentheses?
I did.
Int. You have to put your answers in parentheses when you're squaring things, otherwise you end up with this weird answer. Yes?
So you said if they ever ask for the impact of the final velocity, it's always the same as the initial, given them the problem.
Given no resistance, air resistance, and stuff like that.
So when you say like originally in the problem, it's like, okay.
Okay? So, right, we know our final velocity, yes? Right? If we didn't put the P, so we'll put it in P, our final velocity is also 101.
So if you say what's like the impulse, that's what it means?
The impulse?
Or like what?
Impact.
Impact that, okay.
Impulse is a different concept. Does that make sense? Okay? Why did I say this? Because maybe you might get a question where it tricks you. And instead of saying the velocity it takes off at, it'll say an object is launched at an angle of 30 degrees. It lands with a velocity of, right? They're giving you the final velocity, but in that case, the final velocity would be the exact same thing as the initial. You have to remember that.
Will they always give you the initial?
And I just gave you a situation where they might not. But they gave you the final instead of the initial. If you remember that they're equal to each other, it makes your life easier. So what you see with projectile motions is there's a lot of little facts that you have to remember. But if you can remember those facts, it makes the math a hell of a lot easier. For example, if you always remember that your velocity at the apex vertically is always a big fat 0. We've now done 3 different types of projectile motion questions, and always when we hit the highest point, our vertical velocity was always 0. Didn't make a difference if we launched it straight up off a cliff, right? Or at an angle, the highest point, the apex velocity vertically is always a 0. Does that make sense? Okay? Cool? Got that? So, we filled out another piece of the key. Now, we need to figure out time, I asked you, right? So, okay? How do you think we should figure out time? Okay? Well, there's a couple ways we can do it. But usually, what do we want to look to first, if we can? Which side do we want to look at first? Y, right? Because we usually start the timer when it takes off and stop the timer when it hits the... And what causes it to hit the ground? Gravity. And what axis does gravity act in? Y. So the Y is usually a good place to start. And if we have enough information, we might be able to do it. Yes? Okay, so now let's look at it. So we know when it takes off here, the Y value is what?
0. No.
50.5, right? As it goes up, the Y gets less and less and less. Due to what? Gravity. Right? And gravity causes it to accelerate, yes? So as we go along, we have to deal with the acceleration due to gravity, acceleration due to gravity. That acceleration due to gravity makes it do what here? Stop vertically climbing, yes? So we know a velocity here, right? And we know a velocity here, yes? And we know the reason that the velocity changes is because of gravity, yes? We have an acceleration due to gravity that acts along this path. We have 2 velocities, and it's obviously going to happen at different points in time. So we could find the time for here. Problem is, the time from here to here is only the what? Half time. But since gravity has the same strength going up as going down, if you can figure out how long it takes to get from here to here, what can you do with that number? What can you do with the answer once you find it? Double it, yes? And if you double it, you find out the total time. So what we're going to solve for first is the half time.
So, $2.
Yeah.
So you're finding the total time, the total velocity between the starting point and the apex.
You're finding the change in velocity.
So to give you the VF.
No. You're dealing with this trip. Just this half.
Yes.
So you're using 2 velocities, acceleration to solve for the time.
So is
Remember, the acceleration formula is the change in velocities over the change in time, yes? So as long as you have any 2 velocities that happen at 2 different points in time, you can use them.
Okay.
So this is when we talked about using V2 instead of VF.
So you're just using the acceleration.
Yes. Antoinette?
Wait, why would it be half time and not full time?
Because you're only going from here to here. Is that the whole trip?
But you are going from there to there.
But when we're using number-wise, we're using this velocity, and we're using the velocity at the y at the apex, yes? So if we're using this velocity and this velocity, those velocities only cover half of the trip.
Okay.
Does that make sense?
Yes.
So we're going to solve for half time. How are we going to do it? We're going to use the initial velocity in the y, right? And the velocity at the apex, right?
So that's VFY, right?
Not VFY, just the velocity of the y at the apex. The VFY technically is all the way over here.
How come we said VF is 101? That, if that's VFY, then wouldn't it also be 101?
No, VFY, there's a difference between this value is the velocity at that angle. The y is not at an angle. The y is the y component, only going up and down.
What's VFY?
VFY is the final velocity of the y at this point. So it's the component of the final velocity.
Is it 0 or no?
No, we just figured it out. It's 50.5.
So it's the same.
It's the same at the end as it is at the beginning. Just with a negative sign because it's going down at this point.
Okay, so this is different than from the last, like when we were solving last time, we would be like 0, like your VFY.
This is a different style of question. You have to remember all the points of it. Okay? So we are only doing half the trip. Yes? Does everybody understand that? So we are using the velocity of the y at the apex and the initial velocity of the y to figure out the time. The half time. Yes? We're using these two values plus the acceleration to figure that out. So we're only working on half the trip. We're pretending the second half of the trip doesn't exist right now. Does everybody understand that? Christina, are you okay with that?
Yes.
No, I want to make sure you understand.
Yeah. So like it's the V apex is just something like just.
It's a velocity all on its own, yes.
Okay.
Wait, Mr. Gonzalez?
Yes, ma'am.
For VFY, why is it empty? Didn't we solve for VFY?
Because I didn't write it down yet.
Oh.
I can pull it in for you. There you go. Feel better?
Yeah.
Okay, good? Yes? No. You need to follow this. Okay? So what formula are we going to use if we have these values and we want that? Everybody. Acceleration formula. Okay? We're going to use the acceleration formula. So we're going to do the acceleration in the y is equal to the second velocity minus the first velocity over the change in time. Yes? Yes? Rearrange the formula. Time is going to go multiplied on both sides. Divide by a on both sides. You get the change in time is equal to v2 minus v1 over the acceleration in the y. Yes? Make sense?
Yep.
And sorry, the V2 is the apex.
Yes, it's the second velocity. Okay, good? Alright? Alright, so what do? We plug in our numbers then. So this would be 0.0 meters per second minus 50.5 meters per second divided by negative 9.81 meters per second squared. Yes? Yes, everybody following? Yes? So that's negative 50.5 divided by negative 9.81, which is cool because the negative divided by a negative gives you a positive. Therefore, we don't end up with negative time, so you know you did all the substitution, right? Right? And you get an answer of 5.15.
Yeah, if you round, it's 5.147.
5.147.
Yes.
Okay.
Don't round it.
Don't round it yet. We don't round until we get to the answer we're being asked. So what are we being asked for? Were we asked for halftime?
No.
No, we were asked for Total time. Yes, ma'am.
So significant digits doesn't apply?
Doesn't apply until you get to the answer of the question.
So then whenever you're given time, what place do you round?
Not until you get to the question being asked, Kelly. So the question was, how much time does it take? Yes?
Yeah, no.
So what is it? Hold on. So let me answer the question. The question was, how much time does it take? So I'm asking you for what?
The half time. Well, the total time.
The total time, yes? Now, in the question, okay, we were given the angle of 30 degrees, right? And the velocity of 101. So we have two significant digits with the 30. So our time should have how many significant digits? 2. So this is your half time, yes? Right? Actually, let me do it this way, so it doesn't get confusing. This is your half time, yes? Do you want half time or full time? Full time. So what do you do to this number? Multiply. So what's 5.147 times 2? 7.29. Right? Which is your total time, but we should only have two significant digits, so what should our answer be? 10 seconds.
So, like, I understand that, but I guess my question is on the paper, like, obviously you have to write in the key what the halftime is, because if you ask it, and like, in the calculator, it'll keep going off, so that's what throws me off, like, how many places?
In the key, I'm not going to grade you if I don't specifically ask you for that piece of information and you get it mathematically, you can put it down to as many digits as you want. I don't care. I'm not going to grade you on is it the right number of significant digits. I only care about significant digits on a question I'm being asked.
Okay.
Yes, Christina?
Also, I'm not sure, like, why are we using the VI? Why are we not using just the VF or like the VI?
We never use the VI once we break it up. We said that in the class yesterday. You never. Once you break that 101 up, you never use it again. Ever.
Like, I just don't, why are we only focusing on the Y if that apex is about everything?
That apex is not about everything. The velocity at the apex for the Y is 0.0, but technically the velocity at the apex for X is what?
87.5.
87.5. Okay? But it goes up like this, and the acceleration due to gravity only acts on the vertical, yes? The acceleration due to gravity is what's going to cause it to crash into the ground eventually. So the gravity is ultimately what affects the time. The timer starts when it comes out of the cannon and ends when it hits the ground. What causes it to hit the ground? Gravity. Gravity only acts on what kind of values? Y values. If gravity didn't exist and I shot this cannon, she'd keep going forever at 101 meters per second. Yes? She would travel indefinitely. But gravity does exist. So gravity is our limiting agent. So since gravity is our limiting agent and gravity only acts in the vertical, that's why we use the Y value.
Because we need the acceleration to have like the negative.
It exists. So since it exists, we have to compensate for it. We have to deal with its effects. And its effects are that it will eventually make this projectile hit the ground. And that's when we'd stop the timer.
And then also, when you say like if there was no gravity, we just keep going forever at 101, why wouldn't we go at 87.5 if it's just like...
Because it has a horizontal trajectory. See, what you're not understanding, Christina, is that 101 is the velocity that comes out of the cannon. That 101 has multiple pieces, but in this case we're saying it has two pieces of it. It has a horizontal component and a vertical component. Those don't actually exist. If you launch something at an angle, the only speed you're going to record with a radar gun as it comes out is going to be 101, right? Mathematically, we can calculate that it has this Y component and this X component, right? As it travels through its path, if you were to keep a radar gun on her, she wouldn't be going 101 the whole time. She'd start off at 101 and she would actually slow down. Why? Because as she goes up, she's losing that upward push. So she would slow down, slow down, slow down, slow down, slow down, slow down, slow down. She'd never stop, but she would slow down because the only energy she would have would be that horizontal energy pushing her across. Does that make sense? Right? When she gets to her highest point, she's lost all of that kinetic energy that originally pushed her up. Yes? Gravity would now pull her, and what we'd notice is if we kept the radar gun on her as she came back down, what would happen to her velocity? it would slowly start to speed up. So let's say she was at 101 here, right? Yes? When she's at the top, she'd only be traveling at 87.5, yes? So it would be like 101 here, then it would be like, let's say 92 here, then it would be 89 here, then it would be 87.5 here, yes? Then it would be 89, then it would be 92. Then again at the bottom it would be 101. Do you understand what's going on?
Yes, the components are of the 101, can we say are the VIX and the VIY?
Yeah, that's what we said.
Yeah, but then how come you can't say that the VI is just VXY?
You can if you want to, but you're never going to see it written that way. If it makes more sense to you, you can, but I'm trying to minimize the number of X's and Y's that are in thing because that's going to confuse more people, I think.
I thought it makes sense.
To you, if it makes sense, fine. But it's a combination of those two values through the Pythagorean theorem. It's the hypotenuse of the two legs of the triangle.
Okay, so it's okay though if I do.
You want to, yeah. But it's never going to be written in a question. It'll say the initial velocity of the object is. It's never going to say the initial velocity in the X and Y is.
Oh, so when they say initial, it's like but I actually know that's like.
You can think of it that way, but it will never say that in the question. Yes, sir.
It's a significant digit of 10 seconds. It's only 10 seconds because your
Angle is 30. Okay? Good?
Why you said the zero doesn't count?
In this case, if I was giving it to you like a question, I would have made it 31, just to make your lives easier. If I was giving it to you like a short answer where you had to show work, I would make the answer 31, the angle 31, that way you'd have no question about it being 2 digits. Okay? Alright, let's keep going. Let's keep going, because we literally have spent the period. Yes, ma'am? No, you have to finish this question. Yes, sir?
I'm just kind of confused with this question. Not on how you got the answer, but the degrees is 30.